In this video, we will be solving trig equations using special angles, which means we will not need a calculator. So we will begin by drawing our special triangles and refreshing on them. So first we have our isosceles 45, which is 1, 1, root 2. Then we have our equilateral triangle that is split in half. So we have our 60 and our 30. The equal sides are 2, the base is 1, and the height is root 3. And finally we have our imaginary triangle. 0 on top, 90 on the bottom, and then 1, 1, 0. Now, we've seen solving trig equations with a calculator where we determine the quadrant our theta is in, then we determine alpha by taking the inverse of our ratio. Instead of using our calculator to determine the inverse, we're going to use our special triangles and identify which of our special angles, 45, 30, 60, 0, or 90, will give us that specific ratio. And then once we know our alpha, we will apply the appropriate quadrant modifications. So for our first equation, we have sine theta equals 1/2. And I know sine is opposite over hypotenuse. So I'm looking for an opposite of 1 and a hypotenuse of 2. So if I look at my 45 degree, opposite is 1 and the hypotenuse is root 2. So that's not good. If I look at 60, opposite is root 3. That's no good. If I look at 30, opposite is 1, hypotenuse is 2. So right away, I know that my alpha is 30 degrees. Now, in terms of the quadrants, I will draw my Cartesian grid here, and I will write in my cast rule. And I see that sine is positive, which means I'm in quadrant 1 and quadrant 2. So now I can figure out my thetas. So in quadrant 1, theta is just the same thing as alpha, which is 30 degrees. And in quadrant 2, theta is 180 subtract 30. So theta is 150 degrees. So those are our two options. Now let's go to the next one. We have cos theta equals -1 over root 2. So with cos, I know adjacent will be 1 and my hypotenuse will be root 2. So if I look at my 45, the adjacent is 1 and the hypotenuse is root 2. So that's perfect. So I know right away my alpha is 45 degrees. Now if I look at my cast rule, I see cos is negative, and cos is negative in quadrant 2 and quadrant 3. So we can apply our modifications. So in quadrant 2, theta will be 180 subtract 45. So theta is 135 degrees. That's one option. And in quadrant 3, theta is 180 plus 45. So theta is 225 degrees. So that's your second option. Now sometimes you have to be careful because your denominator is already rationalized, meaning the radical is no longer in the denominator and it has moved up. So you have to kind of undo the rationalizing to see the trig ratios as they would appear exactly from the special triangles. So if we look at this next example, we have tan theta equals root 3 over 3. If I look at all of my triangles, none of them have a side length of 3, which means this must have been rationalized. So that means at one point, the numerator and denominator were multiplied by root 3. So I'm going to undo that. So if at one point the numerator was multiplied by root 3, then there should have been a 1 in the numerator because 1 times root 3 is root 3. And for my denominator, it must have been a root 3 because root 3 times root 3 is a whole number 3. So now I've undone the rationalizing, and now I can look for an opposite of 1 and an adjacent of root 3. So right away, I already know it's not my 45 because there's no root 3 here. And now I can look at my equilateral triangle. Opposite to 60 is root 3, so that's no good. But opposite to 30 is 1, and adjacent is root 3, so I know that my reference angle is 30 degrees. Now for my cast rule, my ratio here is negative, and tan is negative in quadrant 2 and 4. So now I can apply my modifications. In quadrant 2, theta will be 180 minus 30, so that's 150 degrees. And in quadrant 4, theta is 360 subtract 30, which is 330 degrees. So those are our two options. So the steps are very, very similar to solving trig equations with the calculator, except we're using our special triangles instead of taking the inverse of a ratio. Now let's try some solving when we have reciprocal ratios. So if we see an equation with reciprocals, we have to undo the reciprocal. So we know cosecant is the reciprocal of sine. So the equation that I'm actually going to solve is sine theta equals negative 1/2, because remember 2 is the same as 2 over 1, so when I take the reciprocal we get a half. Now I can go to my special triangles and look for an opposite of 1 and a hypotenuse of 2, and if I go look above, I see that for 30 opposite is 1 and 2 is the hypotenuse, so alpha is 30 degrees. But I know I have to think about my quadrants, and sine is negative in quadrant 3 and quadrant 4. So now I can make my modifications. In quadrant 3, theta is 180 plus 30, so that theta is 210 degrees. And in quadrant 4, theta is 360 subtract 30, so theta is 330 degrees. So those are your two options. Now for the next one, we have cotangent theta equals 1. Cotangent is the reciprocal of tan, and the reciprocal of 1 is 1. So I'm actually solving tan theta equals 1. So I want to put this first into a fraction. So I see that my opposite is 1 and my adjacent is 1. So if I go up above and I look at my 45, opposite is 1, adjacent is 1. So I've already figured out my reference angle. Alpha is 45 degrees. And now I'll use my cast rule to see where tan is positive. And it's positive in quadrant 3 and quadrant 1. So in quadrant 1, theta is just the reference angle, 45 degrees. But in quadrant 3, theta is 180 plus 45, which is 225 degrees. And there we go. And now our last one, we have secant equals undefined. So if it's undefined, that means at one point we divided by 0, and we probably divided 1 by 0. And we know secant is the reciprocal of cos. So we're actually solving the equation cos theta equals the reciprocal of 1 over 0, which is 0 over 1. And that means we're looking for an adjacent of 0 and an hypotenuse of 1. And this weird scenario is going to be in that imaginary triangle. So if I go up above and I look at 0 and 90, if I use 90 as my reference angle, adjacent is 0 and hypotenuse is 1, which is exactly what we want. So our alpha is 90 degrees. And now we can use our cast rule. Cos is positive in quadrant 1 and quadrant 4. So in quadrant 1, theta is the same as alpha, which is 90 degrees. And in quadrant 4, we're going to do 360 subtract 90, which is 270 degrees. So those are our two options for theta. And that's it. So we're using our ratio to identify the correct special angle, whether it's 45, 30, 60, 0, or 90. We look at the cast rule to see what quadrant we're in. And then we use the quadrant and our alpha to figure out our two values of theta between 0 and 360.